Welcome back. This video is going to show you how to do one of the synthetic proofs. And so it's out of order. This is, even though this is the fourth video, these synthetic proofs came before the coordinate geometry proofs. All right, synthetic is made up, so they have to give you information, whereas the coordinate geometry proofs, you calculate everything yourself. So, arguably, these are a little less work if you know how to do them. So we make up the situation, okay? We tell you that all this other stuff's just describing what you're seeing. Right here is the first piece of information that we can actually utilize. So it's ADG is this three-letter path creates that angle. BCG creates that three-letter path, that angle. Basically, we come through and we mark that those angles are congruent. Now, it's a rectangle, which gives us more information. These two angles are not only right angles, but they're also congruent. The way I'm going to complete this proof, I'm actually better off saying they're congruent. Okay? And lastly, I'm going to show those are congruent. Now, if you look carefully, okay, I'm just going to highlight this triangle. This right triangle here, right, is going to be congruent to this other one. And that's going to be by angle, side, angle. Okay, so what I'm going to do first is show the triangles are congruent by angle, side, angle. And then I'm going to be able to demonstrate that B to F is the same as B to E. Okay, that's by corresponding parts of congruent triangles are congruent. And then basically what we're going to do is we're going to cut EF out of AF, and that's going to leave us with A to E. Okay. Let's see. If we take BE and take away EF, we're left with BF. Okay, that's segment subtraction postulate. That's something we'll get into in more detail in a minute. But that's our overall plan, and we're going to piece it together here right now. So let's go through. All right, first and foremost, I have to, even though it's given, I have to say ABCD is a rectangle. I'm going to write the statements. I'm going to let you fill in the reasons as I say them, just to be a little bit faster with the video. So next thing I'm going to do is I'm going to say angle A is congruent to angle B. Now, some people would argue with me, well, shouldn't you say the right angles? Right angle isn't actually helping me when my goal is angle, side, angle. With angle, side, angle, the A is telling me I have a pair of congruent angles, or a pair of angles that are congruent. So telling somebody that they're right angles actually makes me go another step by saying all right angles are congruent. So some people would, and that's okay, that's up to them. But angle A is congruent to angle B, and that's simply because, I'll write this one out. This one's a little different. All angles in a rectangle, all interior angles in a rectangle are congruent. Okay, so that gives us one less step than we originally were going to have. All right, so now it's going to be AD is congruent to BC. You fill this in as I say it. Its opposite sides in a rectangle are congruent. Yes, that's also a parallelogram property, but you can say that. Make sure you say rectangle. Don't say parallelogram. Next, they told us ADB was the same as BCG, so we'll write that down. Angle ADG is congruent to angle BCG, and that was given. You can go ahead and write that. And now we have the triangles congruent. name it right, please. Congruent to triangle, EDC, and that's by the angle side angle triangle congruence theorem. Okay, 6, AF congruent to BE. And that's by corresponding parts of congruent triangles are congruent. All right, this is where it gets a little weird. Okay, so AF is the same as BE, right? So if we subtract the same amount from both sides of things that are congruent, that should be equal. So that's subtraction, property of equality. Okay, so that's like saying, I'll do this off to the side here. That's like saying if you know x plus 3 is 10, right? One of our algebra moves is to subtract the same amount from both sides. That's legal, okay, because we're subtracting an equal amount from both sides. That's subtraction, property of equality. It's an algebra property. Now, somebody might argue that that's not a great way to do that proof. You're skipping a step. Yeah, they could probably take a point off from this, but for a homework assignment, it's okay. A lot of teachers would accept it. I wouldn't take off on a Regents exam for that. Okay, I get where you're going. Now, again, this is another one where I'm probably skipping too many steps. Okay, so I could say now that AE is congruent to BF, and that's by, all right, it's not really simplification, but I'm going to say it anyway. Basically, I'm saying A to F minus E to F is A to E. B to E minus E to F is B to F. Okay. That was up top where I talked about subtraction, segment subtraction postulate. Again, this is nitpicky stuff. Somebody might even skip step 9. That is equal lengths. Segments with equal lengths. Tells us they're congruent. Something like that. So this isn't